Recording progress.
Welcome. I just see a CEO one. So we're going to touch on 3 videos on algebra, just to touch base on some of the revision concepts. We will touch on Algebra 1, which appears usually on both paper 2 and 3. So we will be touching on algebraic manipulation and simplification. Before we delve into any problem solving, it's always very important that you study with your syllabi. So the syllabi tells you exactly what you need to do. You're already told in this case to simplify expressions by collecting like terms. So any expression at all where you're expected to collect like terms and add them, subtract them together, or multiply them, then you end up with a simplified version, something more or less like that. Then as well, you must have the ability to expand products of algebraic expressions. By the word product, it means basically multiply. So if you have something that is in brackets, please try and remove the brackets and then expand it out, then further simplify it. You might also be given problems where you need to deal with double brackets or triple brackets. And I've seen that triple brackets have been quite common in the recent papers that were written in May, June. Then, of course, factorizing. And factorizing by common factors, otherwise what we refer to as the highest common factor, very, very important. Often at times the terminology that comes across in the exams is factorize by means, factorize basically means factorize fully, which means you must really use the highest common factor. I'll show you that. Then you can factorize any expression that comes in any of these forms. The only 2 unique ones here would be this guy, which is quadratic. So that I will not cover in this video. I'll cover separately after this video so that we can just focus on those, because that skill is also required for solving algebraic expressions. The rest is just basically the same thing. You need to look for the highest common factor. So all of these ones here, you really just need to look for the highest common factor. This as well can then obviously be difference of squares at times, which I will also show you. A skill also required when you are actually solving algebraic expressions or simplifying algebraic fractions. So those are quite important. Then lastly, one of those things that I know many of you don't like as much is also completing of the squares is very, very important. So they can ask you something like that as well. So I'll show you all of those, but for completing of the squares and factorizing by the quadratic method, I'll only show that in the second video. All right. Then thereafter, we will look at basically your algebraic fractions. And you would see the syllabi also gives you all these examples. You could see here solving algebraic expressions where you are adding them, where you might be subtracting them, where you are multiplying them, where you divide them, and then where you've got expressions with more than one term. As you could see here, that's my numerator with 2 terms. Then I need to do equally the same thing that I did here. I think the one that requires the skills that I just spoke about above is this one, because then this one tells you must first factorize, then simplify these rational expressions. Now, these rational expressions usually come with expressions on the numerator and the denominator. So the first thing you've got to do here is identify what type of expression you are given as a numerator or denominator. So if I look at this example in the syllabi, this here is just a common algebraic expression with a degree of 2, which simply means that I can actually factorize this by the highest common factor. And then this one here is a quadratic expression, which means I must factorize by the quadratic expression. Then the skill is obviously you want to make your numerator and denominator to have common bracket so that the common brackets can cancel out in the end, and then you simplify it. So often at times what they do in the exams is they can give you something maybe on difference of squares, either as the denominator or numerator, or they give you something like a quadratic expression. Then you must first factorize before you simplify. So I've seen this question being asked on both papers as well. So likely it should be asked again. So you should know the skill. And then the last one is the indices. Indices is really a question that comes and pops up every now and then. So it's very important that you also do know. Now, these indices are actually divided into two parts. You will be asked to either simplify fractional indices, or they will ask you to basically first solve an index. And to solve an index, you must have the understanding of trying to make the bases the same. Like, for instance, the first couple two here, when they want you to solve, your exponents are always going to be x. And to solve this, we must make the bases the same. So you can just highlight that already on your syllabi, that at this particular objective, I need to attempt to make the bases the same. Then finally, these are the fractional indexes that we'll also be going through with a few couple of examples. And like I said it in class, we will not need any knowledge of logarithms because logarithms are out of the syllabi. All right, so I just wanted to quickly go through an inset of the syllabi, just so that you just understand exactly how you must approach these questions. All right, so without wasting time, let us then start. So like I said before, one of the crucial skills that they will ask you in an exam is to simplify your algebraic expressions. So simplifying algebraic expressions really is all about collecting my like terms. So what I like to do usually at times, I just like to mark out my like terms, and then I can simplify by collecting my terms. So a simple expression like this, I have 7c plus minus 5d plus c plus 3d. So what I will do is I have 7c as first. I'll collect the c's. And when I'm collecting them, I'm not changing the signs. Don't change the signs. Just basically drag and drop. So plus c here. And then you could see here, I still have my minus 5d plus 3d. Then all I need to do is to obviously simplify. So 7c plus 1c will give me 8c. And then here, be careful because it's a negative 5 plus a 3. You are adding 3 to a negative 5. So obviously the bigger number is 5. So you're going to end up with minus 2d. You can't go a bit further than that. So that is simplified. Or you've got something more or less like this as well, where you are told to simplify. So I took this one directly from the syllabi. So again, I would actually want to just mark out my like terms. Then I know for a fact which ones I will deal with. Then again, drag and drop so that I have my 2a squared plus 5a squared plus 3ab minus 9ab. And I'll just write again minus 1 plus 4. I've collected my like terms. Now I can compute. So 2a squared plus 5a squared. Please be careful here now. When you are adding algebraic expressions, please don't attempt to add the exponents. The exponents only add when you are multiplying. So 2 plus 5 will give me 7. 7a squared, not 7a4. That's only when you are multiplying. All right, then 3ab minus 9. So be careful because you're subtracting 9 from a smaller number, so you obviously expect to get a negative. So that would be negative 6ab. And then plus, then you could see here is minus 1 plus 4. which will literally just give us plus 3. And just like that, you have simplified your algebraic expression. Just pay attention, please, when you are collecting the like terms, not to change the signs. And do not add the exponents if it's not multiplication. All right. Next up, another example. Again, these are just typical examples I took from the recent papers so that you can just see that it was not as difficult as you might think. So here again, you are simplifying, but obviously then I am multiplying. Multiplying is just all about joining things together. So 5 times 7, pardon me for that. All right, so 5 times 7, yes, what's 5 times 7? 5 times 7 is 35. And then you take a look at that, and you take a look at that. Now it's the time to add the exponents. So because these two are the same base, so you just add the exponents together. So 5 plus 3 will then give me x to the power of 8. And then here I have y and y2. If there's no number, there's always a 1. So 1 plus 2 will give me 3. And just like that, I've actually simplified that. All right. So this is just about simplifying. Just be careful, like I said before, that you only add the exponents when you're dealing with multiplication. If it was division, it will be the other way around. Division, you don't add the exponents, you subtract the exponents. All right. Then again, expand and simplify. And really just the basic things. Just pay attention to the signs. Very, very important. Pay attention to the signs. So here, I'm given this expression, and I need to first, obviously, you need to always apply bit mass. So you've got to get rid of the brackets first. So I need to first try and compute this. So I need to multiply everything inside here by not just x, there's a negative thing. So I need to multiply this, everything inside by negative x. So I'm going to have negative 5x if I do that. And then the negative x multiplied by a negative x squared. Now remember, I'm multiplying, so I'll add the exponents in this case. So negative x multiplied by negative x squared will give me positive, because there's a negative multiplied by a negative, positive x cubed. Now I've already gotten rid of the brackets. So this 2, which 2x I didn't use, I just drag because it wasn't joined to the brackets. So I just bring it down. Then obviously these two are like terms. I can further compute. So that would be 2 minus 5, which will basically give me negative 3x plus x cubed. So that is simplified. And it is expanded. So just again, pay attention to what needs to be done. Be careful with the signs outside the brackets before you actually expand. Right. Then next up is the triple brackets. Now, triple brackets really, I've seen that they have appeared in almost all the papers that were written recently since February and March and May and June. It might not appear at the end, but you never know. All right, so with triple brackets, the first thing you want to do is to first compute the first two brackets. First, you compute the first two brackets. And like I said before, you must multiply everything inside the first bracket with everything outside the second bracket. So that will be x times x, which will give us x squared. And then x times negative 3, which will give us basically x negative 3x. And then I'm done with the first part. I move to the next one. 4 times x will give me positive 4x. And then 4 times negative 3 will give me negative 12. Now, what I've done here, guys, is that I've just computed the first part. So I can still leave this for now, and then I can simplify this first, if there are any like terms, that is. Clearly there are, so these two are like terms. So I'll first compute the 2, so that's negative 3x plus 4x. That's going to give us negative, not negative, but positive x minus 12. Now that I have that, I can then multiply this with the other bracket as well. I could have just put this bracket first, but it's okay. You can still do it the same way. Then again, I go the same way, so I'm going to have to multiply. I like multiplying like this and not like that. So I'll then multiply everything inside this brackets with everything in the other bracket. Or I could have just done it the other way and then also just do this, still the same thing. So this times this will give me, remember it's times, so it will be 3x times x squared will give me 3x cubed, and then 3x times x here will give me 3x squared, and then 3x times negative 12, that will be negative 36x. So I'm done with that part. Then I move on to the next one. 2 times that will give me plus 2x squared. And then 2 times x will basically give me again 2x. Then 2 times negative 12 will give me negative 24. Right, if I made any mistake, you can obviously correct if you have more time to do that. So then obviously you start collecting your like terms. That and that are like, and this and that are like. So you'd end up with an expression now. If you simplify it, it will be 3x cubed. And there's a reason why it has to be cubed, because then there were 1, 2, 3 brackets and 3x values, so it will be cubed. All right, so then you have that 3 plus 5, 3 plus 2 will give you 5x squared. And then you have negative 36 plus 2x, that will be negative 34x minus 24. So just like that, you are done simplifying. And this can also happen, this can actually appear on the non-calculator paper as well. So just bear that in mind. So you just need to know how to multiply. Right. So generally that's you dealing with expanding of the brackets. And like I said, it has appeared on both papers. So do expect maybe similar questions to also come in either one of the papers that you sit for. Right, then, like I said, on the syllabi, you are expected to also factorize. And literally, there are 2 ways in which they would probably want you to factorize, apart from what I said now, your quadratic factorization and then completing of the squares as well. You need to factorize by grouping, and you need to factorize by the highest common factor. So here, clearly, you've got more than one term. More than 2 terms. So you have to group. And you group things that have a highest common factor in common. So clearly, this one's, it doesn't matter which one I group, really. I'll just get the same thing. So I can group this one and this, and this and this. So here I can see that the highest common factor of this is y, so I can factor y outside, and I'll have 3 minus x. And then the highest common factor of 15 and 5 is literally 5, so I'm going to write 5. And then 5 into 15 is 3, so that my brackets are already starting to appear to be the same. Then 5 into negative 5 will just basically give me negative x. Then I now know my brackets are the same, so I can group the uncommon and the common. And just like that, we have factorized. Quite easy, actually, and quite neat. All you really have to do is just again pay attention to the ones that you need to pay. Here it was straightforward, but sometimes you can pay. I mean, you could have paid the 5 with the negative xy, and you could have also paid the 15 with the 3, and you end up with the same thing. Just do not change the signs. All right. Another typical example of what we're just saying now. So if you could look at this one now, for instance, equally the same. I think I can just group this one and that one and this. Because I can already see 5 and 10 have got something in common. The 2a and the negative ax have got something in common. So the highest common factor of the first two is 5. So I can factor out the 5. Then that will be 5. 5 into negative 10 is literally negative 2. And then here, what's common is the a. So I can factor the a outside. And then here will be my x. And then here will be negative 2. Because then negative a times x will give me negative ax, and negative a times negative 2 will give me positive 2a. Brackets, as you can see, are common, so I can then take the uncommon, 5, negative a, x minus 2. And there we go, factorized. So typically these questions are usually about 2 marks. They can ask you 2, they can ask you 1, but 2 marks is 2 marks. All right, so then you move on to this one again. This, as you can see, is literally straightforward because then you just expect you're only given 2 terms. So this is just factorizing by the highest common factor. So we need to look for the highest common factor of 12 and um, and 28. Now, many students here make the mistake of saying, okay, I'll just use 2. If you use 2, you might realize that you have not factorized completely because then you might still end up with something. Let me just give you an example. If I said the highest common factor here was 2x, then I'll probably say 2x into 28 is going to be like what, 14. So I'll do that. And I'll have like 14y minus 6. But you can still see inside these brackets, the 14 and the 6, again, their highest common factor is going to be 2. So you don't want to use 2 because 2 is not necessarily the highest common factor. So it's very important that you find the highest common factor of the numbers, other than just using the one that is close to your heart. You must use the highest common factor. And you can obviously use prime factorization if you are not sure, and then you can then simplify. All right, so let's move on to do this one then. So what's the highest common factor of this one? The highest common factor of 28 and 4, 28 and 12 is literally 4. So with that said, 4 will be the highest common factor. However, you can also see that they have variables in common here. So it will also be 4x. And then 4 goes into 26, 4 goes into 28, 7 times. So that means 7y. And 4 goes into negative 12 3 times. So that will be minus 3. And as you can see here, my brackets, I can't simplify any further, which means I have factorized fully. And then again as well, 2 marks. All right. So that's literally it when it comes to really factorizing and going through some of those basic problems and stuff like that. So I'll do this last one, and then thereafter we will move on to something else. So clearly, again, this one now, you see, I can't group the first two because they've got nothing in common. So what I can do is try and rearrange so I can have those ones that are in common close to one another, because I can't just go like this. There's nothing common in the first two. So I can literally say, okay, y with plus 2xy, and then probably minus 6 minus 3. But it's very important now, the way I arranged it like this, it will make it difficult for me to factorize, because if I factorize this, I want the same letters to appear in the brackets first. So again, I could still rearrange this and literally put the 2xy in front. You'll see why I'm saying that. Rather than having it like this, I can then say 2xy plus y minus 6 minus 3. The reason is when I do factor the y out here, which is the common, x must be the first one in the brackets, and it must also be the same thing on the other side. So again, now here I can group, and then the highest common factor here is y, so I'm going to have y like that, and then 2x plus 1, and then here the highest common factor of negative 6 and negative 3 will basically just be negative 3, and this into that will give me positive 2x. You see now why I said I want to arrange them in that way. Yes, and then you have this into that, it will basically give me negative 1, positive 1. Then I group the common with the uncommon, so that would be y, negative 3, and then 2x plus 1. So just be careful with this. You want to rearrange in such a way that when you factorize, you don't get the challenge of, maybe you put the y first and then you factorize these brackets, but they don't look the same as the other ones. Just rearrange them in such a way that they will align. All right. So that was it for simplifying algebraic expressions, dealing with factorization, expansion, and so forth. What is also common in these papers is they are asking a lot about the algebraic fractions. So it's very, very, very important that we please know that. And then in another video as well, we will also touch on how we can solve this when this whole thing is probably equals to a number. And then we will move to the part where we are expected to simplify algebraic expressions as well. Now, some of the common key rules that I always write down before I solve all of these things is when I gave you that structure of, if I'm adding algebraic expressions, then it comes in the form of A over B plus C over D. Then all you need to really do to simplify this is to cross multiply. So that would be A multiplied by D, and then B multiplied by C, and then finally B times D to simplify it. And this works for both addition and subtraction. So following this rule, then that will be 2 times x, which will obviously give us 2x. Now be careful when you have terms, more than one term multiplying with a single term, please put the other terms in brackets. So 3 times this will literally give us then 3 on the outside, and then 3x minus 4. So I've done that. This is just for the numerator. That cross multiplication is for the numerator. And then the denominator, you would see we just do the b times d. So that's the numerator done. Now the denominator will literally just be 3 times 2, which is 6. Now that's not simplified because you need to simplify it. So you can obviously see if you can collect any like terms. So yes, we can expand this, and then we're going to end up with 2x plus 3x minus 12 over 6. You could have skipped this step and just go straight forward. So 2x plus 3x will be 5x minus 12 over 6. Is as clear as that. So similarly as well, it's the same thing. It's literally your A over B minus C over D in this case, because it's in subtraction sign. So again, cross multiply, that would be 2x. 2 times 2x will give us 4x. And then be careful here, please. You're multiplying this 3 with a 3 outside and the whole thing. So, but in this case, you can just say 3 times 3, and then that will affect the brackets as well. So 3 times that, the numerator now, so that would be 9 on the outside. The brackets will be affected by that now as well. And then 3 times 2, which will give us 6 again. So again, here, just be mindful that it's just not positive 9. When you're going to expand the brackets, it's negative 9. So it's negative 9 times x. That will be negative 9x. And then you have 9 times 5. 9 times 5 is 45. 45. And it's positive 45 because it's negative 9 times negative 5. So it's positive 45. And then here you're going to end up with 4x over 6. Then you take away the 9 from there. You're going to end up with a negative 5x plus 45 over 6. Now you can leave it there. You don't need to go further. Although you could possibly also factorize this as well, but there's no need for that. All right, so moving on to multiplication and division. With multiplication, we don't cross multiply. Multiplication is literally joining things together. So it's basically literally your A times your C and your B times your D. So just pay attention to your exponents. So if you have 3a times 9, what is 3 times 9? 3 times 9 is 27. So that will basically be 27, but be careful. You are dealing with exponents there as well. So that will be a 1 and a 1 there. So that will be 1 plus 1. So it's 27a squared. And then 4 times 10, that will be 14. And obviously, if there's a way to simplify your fraction, then you also equally simplify. Now, like we said before as well, this is joining and that's also joining. However, these two processes are just a reverse process of each other. Before you solve anything division, you always need to reciprocate. So here, first thing I've got to do is if I have 3a over 4 divided by that, I need to get rid of the division sign. And to do that, I need to first reciprocate. So this two will basically just swap or exchange. So the 10 goes top and the 9 at the bottom. Now, as soon as I end up with that, I end up with a multiplication sign. So, and if I do have a multiplication sign, we know multiplication is joining. So that will just literally be 3 times a. And then at the bottom, that will be 4 times 9. Please, this is not a negative. I'm just indicating that you need to multiply. So that will then end up being 38 divided by 36. 36a then. And clearly, here you can see I have a and a on top. So this basically will cancel out and this can simplify. All right, so literally, and then you can just simplify the fraction. I'm not going to simplify that for you there, but you can simplify the fraction. All right, so that is really just about it when you're dealing with the basic algebraic expressions. Now, on another note, you do get those ones that seem challenging, but they're not. It's just the same thing. This is the same thing as A over B because then you have a plus sign. So again, you're going to do that A over B plus C over D. Just be careful. You can see there's more than one term. So you need to put this in brackets already from the start. So that will be 1 times that. That will be x minus 3. And then here you can see that you're multiplying these two brackets together. So that will be plus x minus 2 multiplied by x plus 1 over x minus 2, x minus 3. Now, in cases like this, guys, you are told to simplify, so don't expand these brackets at the bottom. You can simplify the numerator because it's not in its simplest form. This is already in its simplest form. So if I have this, the first thing I've got to do here is I need to first expand these brackets. So that will be x times x, which will give me literally x squared. And then x times 1, which will basically just give me x. And then negative 2 times x will give me negative 2x. Then negative 2 times 1 will literally give me negative 2. And I still have the other x minus 3. So first, let's simplify this. See if there are any like terms. So this guy, and that guy are like terms. And the value here and that value there are like terms. So with that said, we will probably then end up with the following. So we can just bring the x squared term first, x squared. And then I've got x here plus another x. That's going to give me 2x. And 2x minus 2x is just literally going to give me 0. And then negative 3, negative 2 is basically negative 5. Now I end up with something that looks like that. And then at the bottom, I've got this. This point, I can't simplify this further. If 5 was a square number, then I would have used difference of squares and then possibly simplify further. But I can leave it just about there. All right, so with that said, that is just you dealing with your algebraic fractions, simplifying them, and so forth. And I said here now, don't go overboard by trying to also expand the denominator. Leave it there, expand the numerator because you can see it's not simplified. You still have a plus sign there. You need to do more here, and which is why now you could see it is actually much better and it's actually simplified. I just hope I did it the right way. So slightly fast. All right. Then comes the questions where you are expected to probably first simplify before, factorize before you simplify. These are called rational algebraic fractions. These are the ones that I was pointing with an arrow at the beginning of this video. Now, what they do here is that they give you two different expressions for your numerator and the denominator. What you need to do first is to first figure out how to factorize the two. Now, I said before, identify the following. Check what type of expression you are given, then you can factorize. And then what you can do here is don't try and do it just speedily. You'll be given enough space. So take your time to first solve each separately. So if I look at the first one, clearly it's not a difference of squares because 2 is not a square number. So it is factorizing by the highest common factor here. And the highest common factor here is actually x. So I could have taken that first as my numerator, which is going to be that. And then I'd factorize this, the highest common factor being x. Leave that out, minus 2. That's my numerator. So I know what my numerator is. Now I've got to take a look at my denominator. My denominator is a quadratic because it comes in the form of ax squared plus bx plus c. All right, so it's quadratic, and factorizing a quadratic, we need to find factor pairs, and then only then can we factorize. So there's 1 here, so 1 times 6 is basically just 6. 1 times 6 is 6, which will just literally give me 6. Now I'm looking for factor pairs of 6. When I multiply them, I get 6, and when I actually add them together, I get -5. What could those factor pairs be? What could those factor pairs be? So literally, to do this, and you can see that I'm getting positive 6, 6. So we can have factor pairs of that, like 3 times -3 times -2 is positive 6 as well. And if I put -3 and -2 together, I'll get -5. So this is indeed the right one to use. Then I go, all right, let me factorize this, break the 5 down into -3x and -2x, which will give me -5 plus 6. Then I end up with what we just did a while ago, which is grouping. So I can group already here and group there as well. Highest common factor of the first brackets would be x. So I put the x outside, x squared minus 3x minus 3 there. And then here would be -2, right? And then x, and then here as well, -3. Then I take the common with the uncommon, then I'm going to end up with something that looks like this. Now, clearly what I've done there now is that we have factorized. Now we need to simplify. So in the beginning, this was our numerator, which we factorized, and this is now our denominator. So we can rewrite the whole thing at the end now. What you will realize is that you will have common brackets. So you can see here, these two brackets are common, so you just cancel them out, and then you're going to end up with a simplified version of this. So this is what you can generally expect. Just be careful, like I said, you can get difference of squares. You must know how to factorize by difference of squares, or you can get a quadratic, or you can get factorized by the highest common factor. Then you simplify. All right, so let's take a look at another example of the same thing. I think I've put for you here. All right. So with this now, let's take a look at this guy. So again, I identify my numerator and then I identify my denominator. So is there anything related to difference of squares here? No, 7 is not a square number. Then I look at this guy and then I realize, okay, 49 is a square number. So these could then be difference of squares where we deal with a squared minus b squared is actually equals to a plus b minus a minus b. Square root of 49 in this case is obviously 7, so my a will probably be 7. And the square root of this guy will be x, so my b will be x. Then already I know to factorize this one, this is my a, that is my b, so that will be 7 plus x, and then 7 minus x. So this is already my denominator factorized. My numerator, like I said in the beginning, my numerator is factorizing by the highest common factor. So here, numerator, the highest common factor is literally x. So if I put x outside, it will be that. Then I can rewrite this now. So it will be x minus 7x over x plus 7, x minus 7. Then again, you can see these brackets are the same, so they will cancel. So my final answer, therefore, will be x. Something that looks like that. So here you must just be careful, which is why I always say, know your first 20 square numbers. Quickly identify that, yes, this is a square number and there's a difference. So it comes in this form. And whenever you're factorizing something in this form, then you just take the square root of that to identify your A and B. Then you can just plug it into the expression that looks like that. You don't even need to write the expression if you know what we are already dealing with. And then you end up with something that looks like that. Straightforward and straight marks. All right. So again, generally the same. Another question taken from one of the recent question papers. I look at my numerator, then I look at my denominator. What type of algebraic expression am I given on my numerator? Clearly, just factorizing by the highest common factor. So I deal with my numerator first. What is the highest common factor of 2x squared and 10? So that's going to be 2x. So I'll factorize it out like that. Then I'm going to be left with x here plus 5. So I factorize that first part. Then I look at the bottom part. And I look at 25. 25 is a square number. This comes in the form, again, of what? A squared minus b squared. So I need to factorize it as a minus b. So with that said, if I square root this guy and square root that guy, I'll get, this is my x and my b is actually 5. Then I can just literally rewrite this and then it will be as such 2x, x plus 5 on top, which is my numerator already factorized. And then now I can just plug all of those other, the x and the 5 into the format of factorizing by difference of squares. Then I'm now going to end up with x plus 5. That's my a plus b. And then x minus minus 5, which is my a minus b. So again, you can see that the idea is to just try and have a common bracket so that they can cancel out. And then you can see that we're only going to be left with this. Pretty straightforward. Like I said before, they might give you something for difference of squares, or they might give you something for like a quadratic expression, then you need to simplify. Again, this one came from a recent paper. As you could see here again, numerator factorized by the highest common factor. The highest common factor is the letter h. So that would be h plus 4. So I factorize that part. Then I move on to this. 16 is a square number. So that comes in the form of ax squared minus b squared, which must give me my a plus b and a minus b. So obviously, if I square this, that will only give me h. And if I square that, I'll only get 4. So I now know what to do. Numerator, we already factorized. Denominator now is, we know it's our a plus b. So that will literally just be h, right, which is our a. Square root of 16, 4, our b, so h plus 4. And then h minus 4. It doesn't matter which one comes first when you write this out. Then this cancels because it's the same. Then you're going to end up with h minus 4. All right. So literally that is what you're expected to do when you are simplifying rational algebraic expressions. So these type of questions are questions that you can expect on your paper 2 or paper 4. Now, and then the one that people really at times find challenging, um, this one I'm just going to take away, is your indices. I do implore you to probably watch Cognito again, just to refreshen your rules on indices, particularly if you're dealing with fractional indices. You will get one or two questions on fractional indices on either one of the paper. And for fractional indices, you can be asked to solve or you can be asked to simplify. So we'll take a look at a few examples of those, and then you take it from there. So a fractional index really comes in this form. So it's like saying A m over n. That's a fractional index. But to really understand these things, you must understand your roots. Say, for instance, a to the power of a half is the square root of a. If I say a to the power of a third is the cube root of a to the power of a fifth is the fifth root of a. This rule literally means the following. To rewrite this, we say a square root, so your n comes here, and then your m literally goes there. So this rule is very, very important, and this is exactly what you could see here. And we are going to apply this rule whenever you're dealing with your fractional indices. So if you had to simplify this, first things first here, it's not just one rule. Here you have a fractional index multiplying with a fraction as well. So the first rule that you can see here is actually the power rule, where you have a to the power of n multiplied by m. The m must first multiply with the n. So with this one, you must multiply that fraction with that, and then you must also multiply it with 4. Remember, it's an index. You're not multiplying 3 over 2 by 4. So that literally would be x2 times 3 over 2 over 4 to the power of 3 over 2. Then you see this I can simplify because in 2 times 3 is 6. 6 divided by 2 is basically 3. So I'll end up with cube root of 3. Not cube root, but just x to the power of 3. Then here now you see I have 4, 3 over 2. This is a fractional index. It's in that form. What do we do with it? This 2 means square root, which means automatically I will have to put the 4 in a square root. But where do I put the 3? I need to put the 3 outside. That's what this rule is all about. See, your n is the square root. Now, we don't put a 2 here because the root already means 2. So you could clearly see here the 2 is the square root. If this was 3, then we could have had cube root. And then the 3, which is the numerator, comes outside. Thereafter, you can compute. Square root of 4 is 2, right? And then 2 to the power of 3 is 8. So it's 2 to the power of 3. If I was to compute that, then I'll end up with 3, 8. Quite simple, if you were to think of it. You just have to know your rules. Without your rules, particularly this one, you will not be able to solve fractional indexes. Then the tougher questions really comes when you need to solve things that look like this. And to solve this, we follow a method called make the bases the same. It's an indices question, so you have to make all your bases the same. So here by base, I'm referring to the numbers that are actually raised to the power. So your 16 is a base, 64 is a base, even 4 here is a base, because 4 is just 4 to the power of 1, even if there is no 1. Now, whenever you do that and you want to make the bases the same, you can always use prime factorization. So 16, 2 into 16 is 8, and 2 into 8 is 4, and 4 into 2 is 2, 2 to 1. And this you can just even do like in pencil, quick, quick. And then you move on to the next ones. 64, 64, 2 into 64 is literally 32. And then 32, 2 into 32 is 16. 16 into 2 into 16 is 8. And then you go again. 2 into 8 is 4. Sorry for not, you might not see 2 into 4 is 2, and 2 into 2 is 1. Maybe just rewrite this elsewhere, perhaps here. So just for it to be clear, you will see why I'm doing this just at the later stage. So please bear with me. I prefer you guys using this method, then you are not necessarily challenged when you are doing something like this. And then 4 is quite simple, because then 4 will literally just be, but this is basically rough work that you do at first. Eh? Now I said I wanted you to make the bases the same. That's what I mean. So all of these ones here are giving you 2, 2. So how many 2's does it take to make 64? How many 2's does it take to make 2? So I can rewrite this now. And instead of writing 16, I'll write 2 to the power of 4. But then I must also be careful, because it's just not 2 to the power of 4. It was 2 to the power. I can just write it like this: 2 to the power of 4, the 16 to the power of 5m, because there was still 5m. Then here at the bottom, the 4 is going to be 2 to the power of 2 equals 2. This is 64. So 64, how many 2's are those? That's 1, 2, 3, 4, 5, 6. So that would be 2 to the power of 6 2n. Now, there's a reason in which we said before, and I said before now, we want to make the bases the same, because when the bases are the same, you can then start to simplify your problem. So if you had to look at this with these two bases here on this side, I can use the law of division, where I can subtract the bases here. Because then the base is the same, it's 2. So I can just say I must take away 2 from 4. I'm going to end up with 2 to the power of 2. But outside, I'm also going to have 5m equals to 2 to the power of 6 2n. But in this case, they just said I must find n in terms of n. So clearly, my bases are the same. When I make my bases the same, the idea is to cancel the bases. So I can cancel this guy and cancel that guy now. And instead of using those two, I'll literally then just end up with the exponents. So the exponents in this case, let me just clear down the other stuff away. I know that this was quite a challenging question for some students, even according to the examiner's report. So do be careful when you're approaching questions that are like this in an exam. So like I said before, the bases are the same, so they can cancel out. Okay? Then you end up with just 2, because the base is cancelled out, so the exponents will remain. 2 equals to 2 to the power 2 to the power of 5ma. And then, or literally, let's not even do it like that. You can just even just do this. You multiply that, or you do that, or you cancel the bases, and then you end up with just want to take a look at what I did there.